In this module, we will discuss the automatic flight control and augmentation system in the Fokker 100 and examine how AFCAS can signal control in pitch, roll, yaw, speed, and thrust. This module will identify and describe AFCAS controls and indicators at the flight mode panel, at the thrust rating panel and thrust levers on the pedestal, at the flight augmentation panel, and annunciations at the primary flight displays. We will also discuss autopilot controls and AFCAS source select push buttons. In the description section of this module, we shall examine the individual function of the auto throttle system, the flight augmentation system, and the automatic flight control system, and discuss how these systems are integrated for automatic flight control and augmentation. In discussing AFCAS controls, we shall focus on flight deck inputs to AFCAS, the associated flight mode annunciations generated, and the resulting aircraft control commands. The operations section of this module examines a typical AFCAS manual flight profile and an FMS-coupled flight profile, together with the associated flight mode annunciations at the PFDs during each phase of flight. The malfunction section of this module will discuss auto throttle and flight augmentation system failures at the multifunction display units and the flight augmentation panel, together with flight director failures at the PFD and reduced autopilot and auto-land integrity. Finally, malfunctions will also focus on an AFCAS flight profile following an engine out. The automatic flight control and augmentation system in the Fokker 100 provides for fully automatic control of the aircraft in vertical and horizontal axes, and in addition provides yaw stability and stabilizer trim. The level of automatic control depends on autopilot flight director status and the active AFCAS mode. With full system capability, AFCAS can provide aircraft control from 35 feet AGL on takeoff to rollout guidance on landing. And with full FMS coupling, AFCAS can provide lateral navigation along the flight path and vertical navigation throughout the flight profile. AFCAS combines and integrates three subsystems: the auto throttle system, the flight augmentation system, and the automatic flight control system. These subsystems work in close association, enabling AFCAS to operate the flight controls through various flight control servo motors. The outputs from AFCAS subsystems can signal control to auto throttle servos for thrust control, to the elevator servo motor for pitch control, aileron and rudder servo motors, and stabilizer and yaw damper servos for pitch trim and yaw damping. We will examine each of the individual AFCAS systems in detail in this module. All three AFCAS subsystems work in close conjunction. Each performs separate functions whilst exchanging data with the other AFCAS subsystems. The auto throttle system provides automatic thrust control, commanding engine thrust to either a selected speed or calculated EPA. ATS also provides for speed protection and stall prevention. ATS can operate independently or with other AFCAS systems. The flight augmentation system provides yaw damping, turn coordination, and stabilizer trim. Yaw damping and turn coordination are automatic and are not dependent on autopilot status. The automatic flight control system forms the principal system for AFCAS. AFCAS provides flight director displays at the PFD, autopilots 1 and 2, and altitude alerting. The AFCAS-related displays are shown on the primary flight display. These displays include the flight director, shown in this example, the flight path vector, and the flight mode annunciator showing autopilot, flight director, and auto throttle status, and active and armed AFCAS modes. All calculations for AFCAS are performed by 3 identical flight control computers, FCC 1, 2, and 3, and 1 dual-channel flight augmentation computer, or FAC. The 3 flight control computers perform calculations for the autopilots, flight directors, altitude alerting, and part of the ATS thrust management. FCCs 1 and 2 control the servo motors that actuate the elevator, rudder, and ailerons. The flight augmentation computer acts as a performance monitor to ensure that FCC commands are within the aircraft operational limits. The principal function of the flight augmentation computer is to provide autothrottle system servo control, stabilizer trim, yaw damping, and turn coordination through rudder support of aileron movements. You will recall that the flight augmentation computer is a dual-channel computer. Failure of a single channel does not, therefore, affect operation of the remaining channel. All 3 flight control computers and the flight augmentation computer receive aircraft system data and various crew selections from the AFCAS-related flight deck controls. Flight and navigation data system input to FCC 1, 2, and 3 includes data from the inertial reference system, air data computers, radio altimeter, engine multiplexers, and VORs and ILS. The FCCs and FAC also receive inputs from the flight management system, information on aircraft configuration and engine, hydraulic and pneumatic system status. Flight deck inputs to the flight control computers come from the AFCAS-related controls on the flight mode panel, the thrust rating panel and the thrust levers at the pedestal, the flight augmentation panel at the overhead panel, the autopilot disconnect push buttons on the control wheels, and the AP disconnect bar at the flight mode panel. Inputs to both FCC1 and FCC2 come from selections made at the flight mode panel, the auto throttle disconnect buttons and thrust lever angle, and thrust rating selections at the thrust rating panel. All 3 flight control computers receive inputs from the autopilot disconnect buttons and takeoff go-around triggers on the thrust levers. As well as receiving inputs from FCC 1 and 2, the dual-channel flight augmentation computer receives inputs from the auto throttle disconnect buttons, thrust lever angle, and flight augmentation panel selections. During the critical flight phases, the FCCs operate together through crosstalk. In takeoff, FCCs 1 and 2 operate together, and in auto-land, FCCs 1, 2, and 3 provide for maximum system redundancy. The flight augmentation computer normally operates on dual channels throughout the flight profile. During all other flight phases, AFCAS operates with commands from a single FCC to single autopilot servos. The FAC monitors FCC outputs. FCC1 is normally in control. FCC control is determined by the engaged autopilot or flight director status. We will discuss side-in control logic in more detail in the AFCS section. Flight director displays from FCC 1 and 2 are shown at the captain's and first officer's PFDs respectively. Normally, on-site data is used for each display. FCC 3 does not produce flight director outputs. FCCs 1, 2, and 3 provide FMA data for display at the PFDs and advisory data for display at the multifunction display units. All 3 FCCs, together with the flight augmentation computer, supply data to the flight warning computer. AFCAS faults that occur in flight are stored by an AFCAS maintenance computer. AFCAS fault messages from the FCCs and FAC can be displayed at the AFCAS maintenance panel located at the observer's station. Flight deck controls for AFCAS are located at the overhead panel, on the pedestal, and on the flight mode panel. The flight augmentation panel on the overhead panel contains push buttons to switch off FAC channel 1 and 2 commands to the auto throttle, yaw damper, and stabilizer trim, depending on fault annunciations in the push buttons. Manual selection of the rudder limiter can also be made at the flight augmentation panel. Autopilot disconnect buttons are located on the control wheels. With the autopilots disconnected, manual electric trim is possible using the stabilizer trim switches. Manual electric trim commands are possible provided at least one flight augmentation computer channel is operable. Auto throttle and thrust management controls are located at the pedestal, on the thrust levers, and the thrust rating panel. The thrust rating panel contains push buttons for thrust limits. The flex button allows temperature values to be entered. Selections for climb, cruise, toga, and maximum continuous thrust control engine thrust to a calculated EPA target. Auto throttle controls on the thrust levers include the toga triggers. Pulling one of the toga triggers on the ground engages the auto throttle provided ATS is armed. In flight, pulling a toga trigger initiates a go-around. Disconnect buttons for the auto throttle system are incorporated in the thrust levers. As we have seen, flight augmentation computer channel push buttons for the auto throttle system are located on the flight augmentation panel. The main controls for AFCAS are on the flight mode panel, located in the center of the glare shield panel. The flight mode panel incorporates controls for speed selection, auto throttle, autopilot 1 and autopilot 2 engage buttons, and the autopilot disconnect bar, heading select and bank limiter controls, mode select push buttons, the altitude select knob, and the vertical speed wheel. Flight Director Flight Path Vector toggle switches are located at either end of the flight mode panel. Selecting the switches on will display the Flight Director at the on-side PFD. Now switch on the Captain's Flight Director. Flight Director command bars appear on the primary flight display as magenta command bars, and the current Flight Director status message appears in the flight mode annunciator. Selecting the Flight Director Flight Path Vector switch up will remove the Flight Director display and replace it with the Flight Path Vector display. Select the toggle switch up now to display the Flight Path Vector. The FMS-generated Flight Path Vector target and aircraft symbol are displayed at the PFD together with the flight mode annunciator. Note that the FPV cannot be displayed on the ground and is flagged, and the target FPA flight path angle is set at the EFIS control panel. Selecting the toggle switch up again will replace the flight path vector with the Flight Director. And selecting off will remove the current display and associated FMA messages. Finally, in this overview, we will briefly examine the operation of AFCAS controls on the flight mode panel. The speed, heading and altitude knobs have two sub-modes, hold and select. In the hold mode, AFCAS will maintain the current speed, heading or altitude. In general, operation of the select and hold knobs is the same. The hold mode is entered by pushing the knob in, and the select mode is entered by pulling the knob out. In the hold mode, It is possible to pre-select a new value by rotating the knob until the desired figure appears in the associated window. Vertical speed is an AFCAS basic mode. Adjusting the vertical speed wheel cancels previously selected vertical modes for the selected vertical speed. The mode selection push buttons allow AFCAS lateral, vertical and combined lateral-vertical control to be armed or engaged depending on certain criteria. In general, an engaged mode cannot be deselected by pushing the Mode Select button. However, an active mode is cancelled when a new lateral or vertical mode is selected. For an FMS-controlled flight in lateral and vertical paths, the AFCAS nav and profile modes are selected. The level of AFCAS control commands depends on flight director, autopilot, and autothrottle selections. For an AFCAS-coupled autoflight, the FCC-generated flight directors should be selected on, the autothrottle engaged, and one autopilot engaged. The following sections on flight mode enunciations, the autothrottle system and the automatic flight control system, give a fuller account of possible selections at the FMP and how these are realized. Flight mode enunciations are displayed at the top of each primary flight display. The FMA should be observed during flight to verify pilot selections at the flight mode panel and to monitor AFCAS control signals to the various modes. The flight mode enunciator is divided into 5 vertical windows. 3 of these windows display information related to vertical flight modes. The active thrust mode is displayed in the thrust window when the rating is controlled to the EPA target or to the lower limit. IAS or mark mode is displayed in the speed window. And vertical path or profile mode is displayed in the path window. Lateral path modes are displayed in the lateral path window. Certain AFCAS modes combine lateral and vertical path commands. These modes are indicated by a single enunciation across the vertical and lateral windows. The status window on the FMA indicates autopilot, autothrottle, flight director, and flight path vector status. Normal indications are displayed in white. In normal operation, the top line of the FMA displays the current active flight mode in green, and the bottom line displays the selected modes in cyan. For full FMA display, AFCAS requires an autopilot or flight director to be on. With no autopilot or flight director, AFCAS does not signal control at EFIS or to the autopilot servos. In this event, manual control is indicated at the FMA by manual thrust and manual speed. With the autothrottle and flight director on and/or one autopilot engaged, normal FMA indications appear in the FMA windows. The type and amount of information displayed depends on the active and selected AFCAS mode and on how AFCAS signals control. Not all windows display information at all times. Certain symbols that appear in the FMA windows together with the active modes augment the information displayed. A triangle suffixed to a speed path and certain lateral enunciations indicate a capture phase. This example shows that the selected speed is about to be captured. When speed information in the speed window displays an E suffix, the display indicates that the elevator controls speed. The thrust window shows that AT is controlling to the climb EPA limit. A speed indication followed by a T suffix shows the thrust is controlling speed. The blank thrust window indicates that thrust is not at the EPA limit for the selected rating. FMS-coupled AFCAS modes are indicated by a boxed symbol in the appropriate window. In this example, only the lateral navigation function of FMS has been coupled. FMS profile coupling displays boxed vertical path, speed and thrust symbols in the respective windows. On power-up, flight directors, autopilot and the auto-throttle system are normally off, and the flight mode annunciator indicates manual control. A full FMA is displayed with the flight directors switched on. Touch the flight director switch now to switch on the on-side flight director. The on-side flight director is indicated by the FD1 symbol in the status box. With the flight director on, the FMA vertical and lateral path windows display their default settings. FD1 is indicated in the captain's PFD, and FD2 is indicated in the first officer's PFD. Alternate sources may also be selected via the alternate source push buttons in the event of an on-side FCC failure. Now arm the auto-throttle system by touching the AT push button. The characters AT are displayed in the bottom line of the status window, indicating that both auto-throttles are engaged and the toga levers have been pulled. Note that the indication in the thrust window has changed to takeoff thrust. AT1 or AT2 are displayed in the FMA status window in the event of an auto-throttle system single-channel failure. At 35 feet above ground level, the autopilot can be engaged. Engage the autopilot now. In AFCAS takeoff mode, below 1,500 feet RA, both autopilots engage. Note that the current autopilot status replaces the flight director status display. AP status displays can show both APs, AP1 or AP2. The legend, FPV, is displayed in the status window when the flight director at the PFD is replaced by the flight path vector display. The thrust window on the FMA displays the pilot or FMS selected thrust rating when the rating is an EPA limit. Annunciations displayed in the thrust window are manual,
takeoff,
maximum continuous thrust,
climb, cruise,
go around, lower limit, override, and retard. FMS signaled thrust control indications are shown by the boxed ratings, takeoff, maximum continuous thrust, climb, go around, and lower limit. We have already seen that speed is indicated as manual with no flight director, autopilot, or auto-throttle.
AFCAS flights without FMS coupling display minimum takeoff speed of V2 plus 10, indicated airspeed and Mach speed above flight level 250 at the speed window. IAS and Mach indicators appear with associated thrust and capture triangles. Boxes indicate an FMS-signaled AFCAS flight together with associated thrust and elevator control and capture phases.
A selected IAS or Mach value is presented by blue IAS or M letters. The boxed IAS indicates an FMS-selected indicated airspeed.
Manual AFCAS flight mode annunciations at the vertical path window include altitude armed, hold, and capture.
Vertical speed, go around,
glide slope tracking and glide slope capture,
and flare at 50 feet AGL.
In an FMS-coupled AFCAS flight, FMS control signals are indicated by boxed symbols for altitude and altitude capture, descent, and approach.
Lateral navigation annunciations are indicated by the heading and heading select annunciations.
In the VOR localizer mode, the lateral path window displays localizer capture and localizer tracking. and VOR1 or VOR2 capture together with tracking indications. VOR1 or 2 is dependent on the side in control.
At 150 feet AGL, the align annunciation appears in green in the lower window line. FMS signaling of lateral control to AFCAS is indicated by the boxed nav symbol. AFCAS combined modes, where vertical and lateral axis control guides the aircraft along a path, is enunciated over both the vertical and lateral path windows. AFCAS combined mode enunciations are the land modes, Land 3 and Land 2 and Rollout. The FMA also displays flight path vector as a combined mode. If a thrust or speed target or a selected flight path cannot be reached or maintained, the associated FMA parameter flashes, and the parameter that is at its limiting value turns magenta. In this example, the combination of vertical speed and indicated airspeed cannot be maintained with the available thrust. Individual mode failures resulting in the loss of armed or active modes are shown by amber flashing annunciations in the individual windows. An AP disconnect, either automatically or manually, causes the AP annunciation in the FMA to flash amber. Pressing the autopilot disconnect button at either control wheel removes the flashing annunciation. With the flight director on, the status window reverts to FD1 on the captain's PFD. Other FMA windows remain unaffected during this flight phase. Autopilot disengagement during autoland results in an amber flashing Land 3 or Land 2 annunciation and flashing autoland caution lights. Pressing the autoland caution lights removes the amber FMA message to indicate available status. Loss of a complete AT function results in an amber flashing AT on the FMA and an amber MAN in either the thrust or speed window, depending on which was being controlled to a target. In this event, press the AT disconnect at the thrust lever to remove the AT annunciation. Note that the amber speed or thrust annunciations remain until the AT is re-engaged. Flight mode annunciator failure is shown by an amber FMA annunciation at the top of the PFD. This annunciation flashes initially, accompanied by a Level 1 alert and the message EFIS at the left MFDU. We have already seen that the auto throttle system on the Fokker 100 is an integral part of AFCAS. We will now detail a fuller examination of ATS controls and indicators, examine thrust control and ATS alpha floor protection, and discuss AFCAS speed protection. The auto throttle system controls engine thrust depending on the active AFCAS modes. Thrust is either controlled to a computed EPA value, which is reached and maintained, or to a selected aircraft speed.
The auto throttle system can be used for takeoff and throughout the flight profile. The ATS provides thrust lever retraction below 50 feet and disengages automatically on touchdown.
ATS operates in conjunction with autopilots and flight directors, but can also operate independently of the autopilots and flight directors. Flight control computers 1 and 2 perform all calculations for ATS throttle commands and EPA synchronization. To perform these calculations, the FCCs receive sensor inputs from the engine multiplexers, on-side air data computers, IRS data, and on-side data from the radio altimeters and flight management computers. In addition, the FCCs receive inputs on current aircraft configuration for flaps, landing gear and speed brake, and system status inputs. The FCCs use the sensor inputs and selections from related panels in the flight deck to calculate maximum EPA, target, and EPA low limit. The Flight Mode panel provides FCC inputs for the ATS Engage request, speed, speed select, and speed hold, and AFCAS mode selections. The Thrust Rating panel provides FCC inputs for active thrust mode and pilot-selected temperature if flexible rating is selected. The toga triggers engage the autothrottle system to provide maximum thrust or flexible thrust if selected. Pulling the toga triggers in flight initiates the go-around sequence. The FCCs also receive inputs from the autothrottle disconnect buttons at the thrust levers. The FCC autothrottle calculations are communicated to the on-side channel of the dual-channel flight augmentation computer. The FAC also receives AT disconnect inputs together with ADC, aircraft configuration, and system status data. Autothrottle channel operation is dependent on the status of the AT push buttons on the flight augmentation panel. With both AT channels operating, ATS equalizes engine EPAs during non-critical flight phases provided EPA values are above 1.15. The flight augmentation computer performs the autothrottle servo commands that move the thrust levers to the required position for the calculated thrust. Thrust lever movement via a series of cables, cross-tie cables, and connecting rods regulates the fuel flow to the engines. Thrust lever angle, or TLA, is relayed back to the flight augmentation computer from sensors at the engines. A tie clutch engages to provide throttle lever ganged operation in the event of an AT channel failure or FAC single channel operation. Controls for the autothrottle system are located at the flight augmentation panel on the overhead panel, the flight mode panel, the thrust rating panel, and the thrust levers. Indicators associated with the autothrottle system are displayed on the flight mode annunciator on both PFDs, the primary page of the MFDU, and local lights. ATS is armed on the ground by pressing the ATS push button on the flight mode panel. Press this button now to arm the autothrottle system. ATS is armed on the ground provided at least one AT channel is operative. Note, the FMA does not currently display AT status. ATS engages on subsequent toga activation. With a thrust setting of 1.3 EPA, pulling one of the toga triggers activates the autothrottle system. The FMA status window now displays AT status. Pressing the AT push button in flight engages the autothrottle system provided at least one AT channel is operative. The flight mode annunciator displays AT to indicate dual-channel AT operation. With no flight director or autopilot, engaging the autothrottle in flight enters the ATS basic IAS mark hold mode. With one AT channel switched off, the thrust levers are moved in ganged operation by the tie clutch. AT single channel operation is indicated by the appropriate AT status indication in the FMA. The autothrottle disconnect buttons are located in the thrust lever handles. Pushing either of these buttons disconnects the ATS. An autothrottle disconnect is shown by a flashing AT symbol at the FMA and an amber man symbol in the speed or thrust window. Pressing the AT disconnect again removes the flashing AT symbol. The flashing AT display is removed, but the amber manual display remains. The autothrottle remains in a standby mode when it is not engaged. ATS automatically engages when the toga triggers are activated on a missed approach to provide go-around thrust control. ATS also engages automatically for alpha floor protection to prevent the aircraft speed from dropping below the minimum speed for safe flight. ATS automatically engages as the aircraft enters the minimum allowable speed range. When ATS engages for alpha floor protection, the autothrottle provides thrust to the go-around limit if AFCAS is in a thrust mode, or increases thrust to maintain VMA, or acquire a selected speed if AFCAS is in a speed mode. AFCAS thrust modes are manually requested at the thrust rating panel and examined by the FCCs. If the requested rating is accepted by AFCAS, the appropriate TRP button illuminates and the active rating is displayed at the left MFDU. In FMS-coupled flights, thrust modes are selected automatically by the flight management computers. The default thrust setting on power up is takeoff power. The option is to select flex mode for a derated takeoff. The autothrottle system controls the engine thrust to either a computed EPA value or to a selected speed. In takeoff and in go-around below 200 knots, ATS controls the thrust to capture and maintain an EPA target. ATS engages on toga activation to provide thrust to the takeoff EPA limit, displayed by the thrust window on the FMA. At 80 knots, ATS declutches to prevent inadvertent thrust lever retardation during the critical part of the takeoff roll. The declutched state is indicated on the MFDU by the white D symbol on the EPA tape. ATS reclutches above 400 feet AGL when a new thrust rating is selected at the thrust rating panel. Assume you are now at thrust reduction altitude and select climb power at the thrust rating panel. With climb power selected, the autothrottle reclutches and the D is removed from the MFDU. Note also the climb power indication in the thrust window at the FMA. ATS also controls thrust to a calculated EPA target in level change, climb and descent. The thrust window shows that engine thrust is controlled to an EPA target, and the speed window shows speed is controlled on elevator. In level change descent, AFCAS computes an EPA lower limit value sufficient to maintain bleed air for pressurization and anti-icing. ATS controls thrust to the low limit.
ATS controls thrust to capture and maintain a speed target in the vertical speed, altitude capture, altitude hold, and land modes.
Speed control on thrust is shown by the IAS T symbol in the speed window. The elevator controls the vertical speed. In the AFCAS profile mode, ATS controls the engine thrust to either the EPA target or the FMS-determined speed target. In this example, climb EPA is at limit and the elevator controls the speed. With the autothrottle engaged, ATS controls thrust lever angle to the required setting. Flight crew can, however, manually override the thrust lever position with the autothrottle still engaged. When the pilot flying releases the thrust levers, the autothrottle servo clutches re-engage and return the thrust levers to the previous position. ATS restores the thrust lever position in all AFCAS modes except level change descent. In level change descent, the autothrottle system maintains the EPA set during the manual override until a new mode becomes active. Manual override is enunciated at the FMA. If manual override during level change descent retards the thrust levers beyond the EPA low limit, ATS advances the thrust levers to the low limit on release. AFCAS performs calculations to provide reference speeds for display at EFIS. These speeds are stick shaker speed, VSS, minimum allowable speed, VMA, green dot speed, VFTO, flap retraction speed, VFR, and the maximum allowable speed. The max is configuration dependent and could be displayed at VMO, MMO, VLE, or VFE. FCC calculations are used by ATS to provide AFCAS speed protection. AFCAS will not guide or control the aircraft to a speed below the minimum speed for safe flight, or to a speed above the maximum allowable speed. Minimum speed protection consists of the minimum allowable speed function, alpha mode protection, and drift down control following an engine out. VMA equals 1.2 VS in takeoff and go-around modes, and 1.3 VS in all other modes. At flight levels above 15,000 feet, minimum speed increases with altitude. AFCAS prevents guidance or control to speeds below VMA. If the selected rate of climb and speed exceeds aircraft performance, ATS increases thrust to the maximum EPA for the active thrust mode. When aircraft speed drops to 15 knots below the speed target, the limiting thrust rating is displayed in magenta, and the IAS mark value in the speed window flashes. AFCAS reduces speed to minimum allowable and reverts to the level change mode. The aircraft subsequently accelerates to selected speed and climbs to altitude. We have already seen that ATS engages automatically to provide stall protection through thrust control.
Alpha floor protection is provided approximately 5 knots below VMA based on the angle of attack and is in standby above 50 feet AGL.
In the event of an engine failure above the single-engine ceiling, AFCAS will control a drift down provided one autopilot is engaged and at least one auto throttle channel is active. In the AFCAS FMS mode, the master FMC commands the drift down maneuver. If an engine fails during vertical speed climb, AFCAS will initially try to maintain vertical speed at the cost of airspeed. During level change climb, AFCAS maintains airspeed at the cost of vertical speed. We will discuss single-engine operation profiles in more detail in the malfunction section of this module. The maximum allowable speed is displayed as a barber pole on the PFD speed tape. This speed is configuration dependent. AFCAS protects the aircraft against exceeding the maximum allowable speed through ATS-controlled thrust reduction and elevator control.
Selections above the maximum allowable speed are shown on the flight mode panel. The speed bug on the PFD, however, indicates the actual maximum speed which is configuration dependent, or the minimum speed if applicable.
Finally, in this section, note that auto-throttle single-channel failures are accompanied by a Level 1 alert, a procedure at the MFDUs, and a local light in the affected system. A double-channel failure results in a Level 2 alert. Auto-throttle failure alerts are inhibited during the flight phases shown. The automatic flight control system is the principal system in AFCAS. AFCS provides the flight director display at the primary flight display for pilot or autopilot control guidance. Aircraft control through autopilot operation of dual aileron rudder and elevator servos, and altitude alerting functions at the primary flight display. All calculations for flight director guidance, autopilot servo commands, and altitude alerts are performed by 3 identical flight control computers. During critical phases of flight, AFCS provides for maximum redundancy. All three flight control computers provide outputs for autopilot servo control in auto-land. Servo commands are a mid-value selected from the three FCC outputs.
During takeoff, FCC 1 and 2 provide calculations for ATS and flight director guidance. When there is insufficient redundancy during takeoff mode, no autopilot can be engaged below 500 feet. This is enunciated on the MFDS.
In go-around mode, control is maintained by the number of FCCs in control when go-around was selected. In normal operation during all other flight modes, a single FCC supplies control outputs. During these non-redundant flight phases, the flight augmentation computer acts as a performance monitor together with the FCC inline monitor. Although in normal operation only one FCC issues control outputs, FCC 1 and FCC 2 both perform calculations for their on-side flight director display and autopilot signals. To perform these calculations, FCC 1 and FCC 2 receive data from on-side VORs, ILS, ADCs and radio altimeters, IRS data, system status and aircraft configuration data, on-side flight management computer data, and engine data. The active AFCS mode depends on flight mode panel selections that input to FCC 1 and 2, and toga trigger selection that input to all three FCCs. Autopilot disconnect is also signaled to all three FCCs. Normally, FCC 1 and FCC 2 provide flight director displays for steering guidance at the on-side PFDs. FCC 3 does not provide flight director display. The off-side flight director can be displayed by selecting the FCC alternate source push button. Faults associated with AFCS are detected by the flight warning system and enunciated at the MFDUs. Failures in land modes are enunciated by two auto-land caution lights at either end of the glare shield. Pressing the auto-land lights cancels the enunciations and displays current land capability at the FMA. During normal operation, the autopilot is engaged on the side of the pilot flying. FCC 1 is the side in control when AP1 is engaged, and both flight directors are either on or off. With neither autopilot engaged and both flight directors on, FCC 1 is the side in control.
FCC 2 is the side in control if AP2 is engaged, or if no autopilot is engaged when Flight Director 1 is off and Flight Director 2 is on. Please refer to the AOM for a complete side in control reference table for AFCS VOR localizer mode.
As mentioned in the AFCAS introduction, the main controls for the automatic flight control system are located on the flight mode panel.
And flight mode enunciations are preserved at the FMA on both PFDs. The PFDs also display FD or FPV depending on selections at the FMP and also for generated speed reference data. Altitude reference data is also displayed at the FMP and PFD.
Alternate source push buttons for off-side FCC selection are located on the outboard side of the main instrument panel, and auto-land caution lights are located on the glare shield panel. In normal operation, setting up the flight mode panel for flight requires both flight directors to be switched on and the auto throttle system to be armed. With flight directors on and the ATS armed, the FMP is ready for takeoff. FCC 1 in this situation is the side in control. At 35 feet above ground level, the autopilot can be engaged. Autopilots can be used throughout the entire flight profile from 35 feet AGL to after landing. Below 1,500 feet AGL in takeoff mode, pressing either of the autopilot push buttons will engage both autopilots. Engage the autopilot on the side of the pilot flying. With autopilots 1 and 2 engaged, both FCC-1 and FCC-2 signal control to the autopilot servos at the control surfaces. Note this is indicated by the autopilot status display in the flight mode annunciator. When not in the takeoff mode, autopilot 1 is engaged by pressing the AP1 push button and autopilot 2 by pushing the AP2 push button. The AP1 status display in the FMA indicates FCC-1 is the side in control in this instance. Autopilots can be manually disconnected by pressing the dual-element AP disconnect button on either of the control columns.
Manually disconnecting the autopilot sounds a double cavalry charge alert.
And displays a flashing AP status annunciation at the FMA. Pressing the AP disconnect again removes the flashing AP status. The flashing AP status is removed and replaced by the flight director status. If the AP disconnect buttons on both control columns fail, the autopilot can be disconnected by pressing down the AP disconnect bar on the FMP. This action is accompanied by a continuous cavalry charge. Automatic disconnection is also accompanied by a continuous cavalry charge and flashing AP status. Re-engaging the autopilot or pressing the AP disconnect button removes the tone and the flashing AP status annunciation. The main controls and indicators for the automatic flight control system are located on the flight mode panel. We have already examined how the flight directors are switched on and how the display can be toggled between flight director and flight path vector. And we have described auto-throttle arming and engagement and autopilot engagement criteria. The remaining AFCS controls on the FMP are for speed, heading and bank angle, mode selection, altitude, and vertical speed, together with indicator windows, select lights, and armed or active indications. On power up, the flight mode panel displays the default setting of speed 200 knots and altitude of 10,000 feet. The heading select windows and vertical speed windows display dashes. Selecting the flight directors or autopilots on in flight enters the AFCS basic modes of heading hold and vertical speed hold. The aircraft maintains the current heading and existing vertical speed. In normal operation, flight directors 1 and 2 are switched on before engine start. Prepare the flight panel for engine start. With flight directors 1 and 2 on, flight director pitch and heading bars appear on both primary flight displays. For the following discussion of AFCS controls on the flight mode panel, we shall assume that both flight directors are on, the auto-throttle is engaged, and at least one autopilot is engaged. The heading control knob on the flight mode panel controls heading hold and heading select. Selected and pre-selected headings appear in the LCD window display above the heading select knob. Dashes indicate the basic heading hold mode. The current heading mode is shown in the heading window on the FMA. Heading hold is indicated by the green HDG symbol.
And the heading bug is shown on the lubber line on the PFD. It is also displayed on the ND.
In the heading hold mode, AFCS maintains the existing heading. Rotating the heading select knob in heading hold pre-selects a new heading. Turn the heading knob to pre-select heading 138. The new heading selection appears in the heading window on the FMP. Note that the FMA indication does not change and the heading bug does not move. Pulling the heading knob activates the heading select mode and cancels all previous lateral modes. In heading select, AFCS rolls the aircraft to the new heading. Select mode is indicated by the green select light on the flight mode panel and the headings indication at the FMA. Turning the heading knob in heading select mode moves the heading bug to the new bearing and rolls the aircraft to the new heading. Pushing the heading select knob enters the heading hold mode. The aircraft rolls out and maintains the current heading. Note the heading bug slaved to the current heading and the heading hold mode in the FMA. The outer ring of the heading select knob provides a manual bank limit selector. Rotating the ring limits bank angle to 15 degrees or 25 degrees. AFCS automatically limits bank angle to 15 degrees below 400 feet AGL. The altitude control has two modes, altitude select and altitude hold. Altitude selections and pre-selections are made by rotating the altitude knob on the flight mode panel. Rotating the altitude select knob in altitude hold pre-selects a new altitude at the flight mode panel. The pre-selection is shown in the FMP window and by the blue ALT in the FMA path window.
Capturing the new altitude can be achieved through vertical speed selection, level change mode, or pulling the ALT select knob. We will focus initial discussion on ALT selection. Pulling the ALT knob commands AFCS to arm the selected altitude.
The current altitude disappears from the ALT tape on the PFD as AFCS steers towards the new altitude. The new altitude is seen above or below the altitude tape on the PFD. When aircraft altitude comes within 750 feet of the selected altitude, AFCS presents a flashing blue altitude entry alert at the PFD. If no autopilot is engaged, altitude entry is signaled by the C chord. At altitude, AFCS captures the selected altitude and enters altitude hold. The FMA indicates ALT in the path window. Altitude hold can be manually selected during altitude change by pushing the altitude select knob. The aircraft will then level off at the current altitude. The window on the flight mode panel, however, displays the selected altitude and not the hold altitude. Altitude hold is also entered by rotating the altitude knob in ALT select mode, through the current altitude and against the direction of climb. Altitude select is used in conjunction with the AFCAS FMS-coupled profile mode. Pulling the ALT select knob sends the new altitude to FMS. FMS then calculates the best path to the selected altitude. Switching between standard and QNH at the EFIS control panel does not affect aircraft altitude in an altitude hold. AFCS retains the current altitude until a new altitude is selected. Vertical speed hold is the basic AFCS pitch mode. Rotating the vertical speed wheel on the flight mode panel enters the vertical speed mode. Rotate the vertical speed wheel to select a climb rate of 1,500 feet per minute. The vertical speed selection is indicated on the FMP and by the VS symbol on the FMA. If the aircraft deviates from the selected altitude by 250 feet, the selected altitude on the altitude tape flashes amber. This altitude exit alert is accompanied by a level 2 alert and the message altitude at the left MFDU. Altitude exit alerts are inhibited during certain flight phases. Vertical speed is used in conjunction with the altitude select knob. Selecting a new altitude in conjunction with vertical speed causes the aircraft to climb or descend to the new altitude at the selected rate. In vertical speed, AFCS controls speed on thrust and the vertical speed on elevator. As AFCS captures the selected altitude, the vertical speed window on the FMP displays dashes, and the path window on the PFD indicates altitude hold. Rotation of the vertical speed wheel cancels other previously selected vertical modes. The level change mode push button causes the aircraft to climb or descend to the selected or pre-selected altitude at a selected speed or a pre-selected speed. If no speed has been selected or pre-selected, AFCS maintains speed hold during the level change climb or descent. In level change climb, AFCS controls thrust to the climb EPA target and the elevator controls speed. In level change descent, AFCS controls thrust to a lower limit and the elevator controls speed. FMP speed settings are shown as speed select or speed hold on the PFD speed tape. Pulling the speed knob enters the speed select mode. Rotating the knob to a higher or lower speed causes the aircraft to accelerate or decelerate to the selected speed. Select on the FMP indicates speed select mode. To enter the speed hold mode, push the speed knob in speed select. In speed hold, the aircraft maintains the existing speed. A new speed can be pre-selected by rotating the speed knob and activated by pulling the knob to select.
At crossover altitude, which, dependent on the IAS Mach number combination, is approximately flight level 250, the IAS display can be exchanged by pressing the IAS Mach selector button on the FMP.
AFCS computes an IAS equivalent for the selected Mach number for display at the speed tape. The FMA indicates Mach in the speed window, and the FMP displays the Mach number above the speed knob when speed is in select or pre-select. The speed select knob is also used prior to engine start to select V2. The outer ring of the knob rotates to the V2 position to select takeoff safety speed.
V2 is displayed on the PFDs. You will recall from the FMS module that V1 can also be entered on the FMS CDU takeoff page.
In the VOR localizer mode, AFCS captures and tracks a selected VOR radial or a localizer course depending on approach ILS selections made at the EFIS control panel. Arm the VOR localizer mode at the flight mode panel. When VL is selected, the mode remains armed until the capture criteria are met. The current roll mode remains active until, in this example, the VOR is established.
In the capture phase, the FMA displays the triangle symbol above the VOR.
When captured, AFCS rolls the aircraft to track the selected VOR radial. During VOR station passage, AFCS maintains the aircraft in a heading hold. AFCS is able to roll the aircraft to intercept a new radial if selected during station passage. For VOR and localizer coupled operation, raw data is used from the side in control VOR and ILS. VOR and ILS can only be flown from one side. The side not in control loses the flight director display since the offside FCC cannot monitor on-side raw data.
The side in control reference table detailed here can be found in the AOM.
Nav and profile modes couple flight management system signals for lateral path and vertical steering commands. When armed on the ground prior to takeoff, Nav engages at 30 feet AGL to provide lateral navigation commands at the flight director, and with autopilot engaged, provides lateral navigation along the flight plan. When armed in flight, AFCS maintains the existing roll mode until nav capture criteria are met. In the profile mode, FMS controls speed and vertical path. When armed before takeoff, profile engages at thrust reduction altitude above 400 feet. When selected in flight, profile remains armed until the engine criteria are met. AFCS maintains the current vertical path and speed modes until profile becomes active. You will recall that altitude selections at the altitude select knob do not disengage profile mode. AFCS nav and profile modes can be used independently or together for a full FMS-coupled flight. A fuller discussion of FMS-coupled flights and non-FMS flights can be found in the operations section of this module. The Fokker 100 is capable of a full Cat 3B auto-land, designated as Land 3. For Land 3, AFCS requires extensive redundancy. FCCs 1, 2, and 3 compare ILS and radio altimeter data from their on-side systems. Crosstalk between the flight control computers results in a mid-value selection passed to flight directors and autopilot servers.
Reduced auto-land can occur when one FCC is unreliable, as one of the sensors may be unreliable or inoperative. With less redundancy, auto-land capability is designated Land 2. ATS is not required for Land 2.
In both Land 3 and Land 2, the aircraft captures and tracks an ILS beam. Provided flaps are at 25 or full, AFCS performs runway alignment, flare, and autopilot-controlled rollout guidance during the high-speed part of the landing roll. The land mode is selected by the land push button at the flight mode panel when the aircraft is on the ILS intercept heading. The green bar indicates that the land mode is armed, and the FMA displays armed glide slope and localizer modes. Until localizer and glide slope capture, the existing vertical and lateral modes remain in control. The localizer will capture provided the intercept angle is less than 90 degrees.
The localizer capture phase is indicated by the FMA, and localizer tracking indicates that the aircraft is established on the beam.
If AFCS is in level change or vertical speed modes and had not reached the selected altitude when land is armed, the FMA does not display glide slope armed. AFCS captures either the new altitude or the glide slope depending on which comes first. On altitude capture, the FMA displays glide slope armed.
And subsequently displays the green glide slope symbol when nearing glide path intercept.
Glide slope capture is inhibited until after localizer capture. With the aircraft established on the beam, with land mode armed, AFCS will attempt to engage the land mode between 1500 and 1000 feet AGL. Land mode does not engage if the glide slope is intercepted below 1000 feet. When AFCS enters the land mode, the second autopilot engages automatically, and the FMA combined vertical and lateral path window displays the land capability, either Land 2 or Land 3.
The missed approach altitude may be set after glide slope capture and not necessarily when land is enunciated.
Below 500 feet AGL, selections at the flight mode panel are ignored by AFCS. At 150 feet AGL, the aircraft starts to align with the runway and the align enunciation appears on the FMA. At 50 feet, flare commences and thrust is retarded to idle. Rollout guidance provided by the autopilot provides control during the high-speed part of the landing roll.
The autopilot should be disconnected before the aircraft has decelerated to 60 knots, although this is not mandatory.
Note that when AFCS self-test determines insufficient redundancy for land engagement, the system remains in glide slope and localizer, allowing a coupled approach and manual landing. During an ILS approach with flight directors on and no autopilot, pitch guidance, displayed at the PFD, is removed below 30 feet AGL. Speed control during autoland ensures the aircraft is established at the correct speed on arrival at the runway threshold. Speed control is accomplished with autothrottle or by manual thrust control. Above 800 feet AGL, speed must be between VREF and VMA. VMA is configuration dependent. Between 800 and 500 feet AGL, minimum speed is VREF and maximum speed is VREF plus 15. Pilot speed selections must be restricted to plus or minus 10 knots. If the aircraft speed is above VREF plus 15, a Level 1 AFCAS speed alert appears at the primary page of the MFDU. This alert clears after speed reduction. If the aircraft arrives at 500 feet with land engaged and a speed higher than VREF plus 23 with ATS on, or VREF plus 15 with ATS off, a Level 1 AFCAS speed alert is presented. In addition, an amber Land 2 is enunciated at the PFD and the glare shield autoland caution lights flash. Pressing the autoland caution lights cancels the alert and the system downgrades to glide slope and localizer. Toga selection or AP disengagement also cancels the autoland caution alert. When the speed at 500 feet AGL with land and ATS engaged is between VREF plus 15 and VREF plus 23, the aircraft automatically decelerates to be established at VREF plus 15 over the runway threshold. Finally, in this learning activity, we will briefly examine autoland capability on the Fokker 100 and the associated autoland status enunciations. If the autoland capability is reduced before land engagement, no land free is enunciated on the left MFDU, accompanied by a Level 1 alert. If autoland capability is lost before land engagement, a no autoland alert is presented with a Level 1 alert. If FCC reliability reduces system redundancy after land 3 engagement, the auto-land caution lights flash and the FMA displays a flashing 3. Pressing the auto-land caution lights cancels the alert and displays land 2 in the FMA. If auto-land capability is lost after land 3 or land 2 engagement, the auto-land caution lights flash and the land indication at the FMA flashes amber. Pressing the auto-land caution lights clears the alert and displays glide slope and localizer at the FMA. Finally, if auto-land capability loss is accompanied by autopilot disengagement, alert cancellation and FMA reset is achieved by pressing either AP disconnect or re-engaging the autopilot. The flight augmentation system on the Fokker 100 provides fully automatic yaw damping and turn coordination irrespective of autopilot status. The flight augmentation system also provides fully automatic pitch trim through stabilizer adjustment when at least one autopilot is engaged. As you may recall from the flight controls module, manual electric trim, manual trim, mark trim and alternate trim modes are operative when no autopilot is engaged. Flight deck controls for the flight augmentation system are located on the control wheels and on the flight augmentation panel at the overhead panel. Calculations for yaw damping, turn coordination and stabilizer trim are performed by the dual-channel flight augmentation computer. The FAC receives system-armed or off inputs from the yaw damper and stabilizer trim push buttons on the overhead panel. The FAC also receives stabilizer trim inputs from the stab trim switches on the control wheels. Stab trim inputs, however, are only realized when neither autopilot is engaged. To perform flight augmentation functions, each channel of the flight augmentation computer receives input from its on-side flight control computer, speed input from the air data computer, and radio altimeter data. Both FAC channels also receive yaw rate inputs from the inertial reference system, together with aircraft configuration and system status information.
In normal operation, both FAC channels are operable. Both channels provide commands to the yaw damper servos for a 6-degree maximum rudder deflection. With a single channel operable, only a 3-degree deflection is possible.
For stabilizer control, one FAC channel is active and one operates as a monitor in standby. If one stab trim channel fails, the standby channel takes over and the related FCC monitors. In the turn coordination function, the flight augmentation computer takes aileron position inputs to coordinate rudder movements.
Rudder support for aileron movements ensure coordinated flight without side slip.
FAC rudder control does not cause movement of the rudder pedals. Pitch trim, to maintain pitch attitude without constant elevator deflection, is achieved by adjustment of the entire stabilizer surface. Stabilizer trim is automatically operative provided at least one stabilizer trim channel is operational, hydraulic power is available, and no internal faults are reported by the monitoring channel or FCC. FAC-controlled stabilizer trim is classed as AP automatic trim, manual electric trim, and mark trim. With the autopilot engaged, the stabilizer is trimmed automatically by the flight augmentation computer in response to automatic flight control system elevator commands.
With no autopilot engaged, the stabilizer responds to manual electric trim inputs from the dual-element stabilizer trim buttons on the control wheels. An alert is presented if both halves of the stabilizer trim switch are operated for more than 2.5 seconds in flight or 1 second on the ground after engine start.
With no autopilot engaged and no trim inputs from the control wheels, the FAC makes use of mark information to position the stabilizer.
Mark trim is available automatically above Mach 0.75.
Faults associated with the flight augmentation system are enunciated at the multifunction display units and at the flight augmentation panel local lights. A flight augmentation computer single-channel failure causes a level 1 alert and all the associated channel push buttons to illuminate on the flight augmentation panel. This alert is inhibited from takeoff power to last engine off. Yaw damper and stabilizer trim single-channel faults are also level 1 alerts. The local lights indicate the fault and the procedure is detailed at the right MFDU. Follow the procedure now to switch off the yaw damper system. You will recall that with only one yaw damper channel operating, rudder movement actuated by the yaw stability system is restricted to 3 degrees deflection in either direction. Now complete the procedure by switching the yaw damper back on again. Yaw damper and stabilizer trim single-channel faults may be rectified by cycling the system off, then on again. Yaw damper and stabilizer trim single-channel failure alerts are inhibited during certain flight phases. A yaw damper double channel fault presents a level 2 alert and associated procedure.
And a stabilizer trim double channel fault also produces a level 2 alert. In this case, a double failure causes an autopilot disconnect.
These alerts are inhibited during certain flight phases. Finally, please note that attitude out of trim conditions are enunciated on the left MFDU, accompanied by a level 1 alert. Pilot flying should be prepared for out of trim conditions, up or down as indicated, following autopilot disconnect. This alert is inhibited during the flight phases shown. For an AFCAS-controlled flight without coupling of the AFCAS FMS modes, the flight mode panel should be set up with the flight directors on. V2 selected and initial departure speed selected. Toga or flexible thrust rating selected at the thrust rating panel, and the auto throttle system should be armed. And initial departure altitude should be set at the altitude selector. Prior to toga activation, the FMA displays manual thrust as active and flight director 1 on. Initial departure altitude is displayed as selected in the vertical path box. On pulling the toga triggers, the heading bug is slaved to the current heading and the AFCAS enters heading hold for the takeoff roll. The auto throttle engages and advances the thrust levers to the maximum EPA rating for takeoff thrust. At positive climb, the landing gear is selected up, and at 35 feet AGL, the autopilot can be engaged. Pressing one of the AP Engage push buttons engages both autopilots. FCCs 1 and 2 control the autopilot servos. Speed is controlled on elevator to V2 plus 10 or 18 degrees pitch. Heading hold maintains the current heading. We shall discuss lateral navigation modes when we discuss the cruise phase. At thrust reduction altitude, the pilot flying selects climb thrust at the thrust rating panel. AFCAS enters a non-redundant flight phase, and autopilot control reverts to single operation. Speed control is on elevator. At acceleration altitude, the pilot flying selects level change on the flight mode panel, changing from control to takeoff speed to control to selected speed. The aircraft accelerates to the pre-selected speed and climbs to the initial departure altitude. Speed control is on elevator and thrust controls the vertical speed.
When cleared to cruise altitude with no vertical speed restrictions, pre-select the new altitude at the flight mode panel and pull the level change mode select. At crossover altitude, replace IAS with mark values by pushing the IAS mark select.
With ATC intervention restricting vertical speed, select the new altitude and then the required rate of climb at the vertical speed wheel. The FMA displays the vertical speed mode and thrust is controlling speed. On reaching cruise altitude, the aircraft levels off and maintains the captured flight level. Select cruise thrust rating at the thrust rating panel and speed at the speed select knob. Speed is controlled by thrust, and elevator controls the vertical path to maintain altitude. So far, the flight profile has progressed in heading hold. With ATC intervention to steer to a new heading, pull the heading select knob on the FNP. Turning the knob rolls the aircraft to the new heading, while the flight augmentation system takes care of turn coordination. Heading select is indicated in the lateral path window. To capture and track a VOR radial, the VL push button is selected on the flight mode panel. The aircraft will intercept and track the selected VOR radial when the intercept angle is less than 90 degrees. Only on-side raw data can be used in VL mode. VOR1 and AP1 indicate the left side is in control. When the aircraft comes in range of the VOR, it rolls to intercept the selected radial. AFCAS maintains heading hold during station passage unless a new radial is selected.
To initiate descent, pre-select the new altitude on the flight mode panel and push the level change button to initiate level change. Below flight level 280, pre-select speed of 280 knots for descent. ATS controls thrust to the lower limit.
Pilots can override the ATS low limit by advancing or retarding the thrust levers. FMA indicates the override thrust mode. AFCAS enters level flight at the selected altitude. Level flight speed is controlled on thrust. Descent to a holding pattern altitude with a vertical speed restriction requires the new altitude to be pre-selected and the vertical speed descent rate to be entered. The FMA shows speed control on thrust. The elevator controls vertical speed. Use altitude and heading select for control in the holding pattern and vertical speed to descend in the holding pattern. When level at initial approach altitude, select ILS frequency and course and approach at the EFIS control panel. Arm land mode at the flight mode panel. The FMA displays glide slope and localizer pre-select. Glide slope capture is inhibited until after localizer capture. At 1 dot of glide slope deviation, the landing gear should be selected down. Between 1,500 and 1,000 feet AGL, AFCAS enters the land mode. At 150 feet, the align phase commences, and at 50 feet, AFCAS performs flare and retard. Finally, you will recall that AFCAS provides rollout guidance during the high-speed part of the landing roll. For an FMS-coupled AFCAS flight, the flight directors should be on. V2 selected and initial departure speed selected. Toga or flexible thrust rating selected at the thrust rating panel, and the auto throttle system should be armed. Initial departure altitude should be set at the altitude selector. And nav and profile modes should be armed. Prior to toga activation, the FMA displays manual thrust as active and flight director 1 on. FMS selected vertical and lateral paths are shown as armed. On pulling the toga triggers, the heading bug is slaved to the current heading and the AFCAS enters heading hold for the takeoff roll. The auto throttle engages and advances the thrust levers to the maximum EPA rating for takeoff thrust. At 35 feet AGL, the autopilot can be engaged. Pressing one of the AP engage push buttons engages both autopilots. FCC 1 and 2 control the autopilot servos. The FMS nav mode engages automatically at 30 feet, replacing heading hold. FMS lateral path commands roll the aircraft to the flight plan heading. Speed is controlled on elevator to V2 plus 10 or 18 degrees pitch. At thrust reduction altitude, the FMS selects climb thrust. AFCAS enters a non-redundant flight phase and autopilot control reverts to single operation. Speed control is on elevator. As AFCAS acquires acceleration altitude, the aircraft accelerates to the FMS calculated departure speed and climbs to the initial departure altitude. Speed control is on elevator and thrust controls the vertical speed. At crossover altitude, IAS is replaced by Mach values. At top of climb, FMS selects cruise thrust rating. Speed is controlled by thrust and elevator controls vertical path. The aircraft remains level at cruise altitude. When selecting a step climb to new altitude, pre-select the new altitude at the flight mode panel. the altitude window indicates a new altitude selection. When cleared to the new altitude, pull the altitude select knob to release the new altitude 2 FMS. When step climb is active, it is indicated by the boxed Alt symbol. When level at the new altitude, AFCAS maintains the FMS calculated cruise speed on thrust. When cleared to descend, select the initial descent level at the flight mode panel and pull the Alt knob. FMS descent is now armed. When the aircraft reaches the FMS calculated top of descent, the descent mode becomes active and speed is controlled on thrust with optimum path control on elevator. If ATC intervention requires that the top of descent is overflown, an immediate descent may require speed brake drag. Thrust is then controlled to the lower limit with speed on elevator. When level at the initial descent altitude below crossover altitude, the IAS display is selected for the speed window. Level flight speed is controlled on thrust. When cleared to approach altitude, select the new altitude at the FMP. If FMS requires more than the thrust low limit to maintain the descent path, no rating appears in the thrust window. When level at initial approach altitude, land mode is armed at the flight mode panel. The FMA displays glide slope and localizer pre-select. An FMS-controlled approach is not discussed here. FMS nav and profile modes disengage automatically following localizer and glide slope capture. Between 1,500 and 1,000 feet AGL, AFCAS enters the land mode. At 150 feet, the align phase commences, and at 50 feet, AFCAS performs flare and retard. Finally, you will recall that AFCAS provides rollout guidance during the high-speed part of the landing roll.
Malfunctions associated with the auto-throttle system, the flight augmentation system, and autoland have been discussed in the relevant learning activities in description. Please refer to these learning activities and to the AOM for references to AFCAS-related failures. An FCC failure results in a Level 1 alert, the amber EFIS annunciation at the MFDU, and the loss of the associated flight director and autopilot channel.
The local FCC fault illuminates in the associated source push button. Pressing the push button switches off the affected system and displays offside data from the alternate source FCC. If an engine fails before V2, flight director pitch demands and, with AP engagement, elevator commands are provided to accelerate and maintain V2 or 18 degrees pitch. At positive climb, the gear should be selected up, autopilots engaged, and speed checked to be minimum V2. If an engine fails above V2, speed at engine failure is maintained. Autopilot rudder servo commands compensate for the asymmetric thrust from a single engine. With FMS-coupled nav and profile modes, the engine out must be confirmed at the engine out page of the CDU to ensure the aircraft follows the engine out SID and profile engages at engine out acceleration altitude. When reaching the engine out acceleration altitude with profile mode engaged, AFCAS automatically accelerates to green dot speed and automatically selects maximum continuous thrust. If FMS profile is not engaged, the pilot flying should select level change at engine out acceleration altitude. The pre-selected initial departure speed then automatically shifts to green dot speed. At green dot speed, pilot flying should select maximum continuous thrust at the thrust rating panel. Please note that level change is not possible below 400 feet AGL. FMS maximum continuous thrust selection is indicated by the boxed MCT thrust rating in the flight mode annunciator thrust window.
Finally, please refer to the AOM, which details engine fail procedures during cruise, approach, landing and go-around.
In this module, we have detailed how the automatic flight control and augmentation system in the Fokker 100 can control the aircraft in roll, pitch, yaw, speed and thrust. And we have seen that AFCAS has full auto flight capabilities from 35 feet AGL after takeoff down to 60 knots on the landing roll. We have seen that AFCAS is comprised of 3 subsystems: the auto throttle system, which controls thrust and speed protection, the flight augmentation system for yaw damper, turn coordination and stabilizer trim, and the automatic flight control system, which provides autopilot, flight directors and altitude alerting. We have examined AFCAS controls and indicators located at the flight mode panel, and discussed AFCAS flight mode annunciations at the primary flight display. In the operations section, we have examined flight mode annunciations during a typical auto flight profile, and we have seen the flight mode annunciations associated with an FMS-coupled AFCAS flight from takeoff to landing roll. Finally, in this module, we briefly examined how AFCAS compensates for an engine out at takeoff.